How do we measure items in the chemistry lab? Well, you can measure mass, or volume, or you can count pieces. In chemistry, we measure mass in grams, and we measure volume in liters. You've probably heard of these measurements. But we count items in a measurement you may not have heard of. It's called a mole. So you may have heard of this mole. This is a little subterranean rodent. It digs holes in your yard and might ruin your garden. But this isn't the type of mole I'm talking about. A mole in chemistry is the amount defined as the number of carbon atoms in 12 grams of carbon-12. So picture a scale and you weigh out exactly 12 grams of carbon-12. And if you could count every single atom in that pile of carbon, you would have a mole of carbon. And if you could count all those pieces, it would be 6.02 times 10 to the 23 atoms. So 1 mole of any substance equals that number of particles of that substance. You can treat a mole like a really big dozen. If I said I had a dozen eggs, you know exactly how many eggs I have. But if I also said I had a dozen cupcakes, you would know how many I had of that as well. A dozen is a dozen no matter what we're talking about. Well, that's how a mole works in chemistry. A mole of particles is 6.02 times 10 to the 23 pieces or representative particles of whatever we're talking about. We could be talking about atoms, we could be talking about molecules or formula units. Now that number is a special number and you need to memorize it. It's called Avogadro's number. It's named after some guy named Avogadro who kind of laid the groundwork to figuring out this number mathematically. He didn't actually figure it out himself, but they named it after him because of all the work he did in getting to that number. So what is a representative particle? It's the smallest piece of a substance. If you have a molecular compound, a nonmetal bonded to a nonmetal, the smallest piece of that molecular compound is called a molecule. If you have an ionic compound, it's called a formula unit, the smallest representative particle of that ionic compound. And if you have an element, a representative particle of that element is an atom. Be careful of the 7 diatomic elements. They're not actually elements. The Brinkelhoffs, bromine, iodine, chlorine, hydrogen, oxygen, fluorine, they're actually made of molecules, not atoms, because they're an atom of that element bonded to another atom of the same element. So here's some other types of questions that could be important for this chapter. So if I gave you a formula unit like this, calcium carbonate, you should be able to tell me how many oxygen atoms there are. And this one's really easy. The little 3 after the O here tells me I have 3 oxygens. What if I said how many oxygen atoms are there in this ionic compound, Al2SO4 3? So if you break this compound apart, it's actually made of these ions. I have 2 aluminum ions. The little charges aren't here, but this would be aluminum 3 plus, and this would be aluminum 3 plus. And the fact that I have this little 3 after the SO4 means I have 3 SO4s. The charges are missing from this as well. These would all be 2 minus. But the point is, in each SO4, I have 4 oxygens. So I have 4 plus 4 plus 4, or 12 oxygens. Now you could do that, or you could treat this little number like a multiplier. If I have 4 oxygens in an SO4 and I have 3 of them, you can just go 3 times 4 equals 12. How about this one? How many ions are there in calcium chloride? Well, I have 1 calcium and I have 2 chloride ions if you break it apart like this. So I would have 3 ions. How about this one? How many ions are there in NaOH? Well, hopefully you recognize this OH as a polyatomic ion. This is hydroxide. So I would have 2 ions in this compound, 1 sodium ion and 1 hydroxide ion. How about this one? How many ions are there in Al2SO4 3? Well, we could break it apart again like we did in the other question. You can see I have 2 aluminum ions, 2 Al3 pluses, and I have 3 sulfate ions, SO4 2 minuses. So 2 plus 3 is 5 ions total. So remember, a mole is 6.02 times 10 to the 23 representative particles. We treat that like a really large dozen. This is called Avogadro's number, and you need to memorize it. We'll be using this number in all sorts of conversion factors later in this chapter and in other chapters. And it works for 1 mole of any substance. It doesn't matter if we're dealing with a molecule or a formula unit or an atom. 1 mole of anything is Avogadro's number of representative particles of that thing. And like I said, we're going to use it in lots of conversion factors to go from one unit to another. So this is a number you need to memorize and know how to work with it in your calculators. Also, you should be able to analyze formulas